As you browse our website looking for certification testers, you may have noticed several similar-looking versions within the overall FiberOwl 7 series. Choosing between the different options can be a bit confusing, so let's find out which one is right for you. Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. Hello, I'm Professor Jim Powers. Let's take this moment to introduce our company, Optical Wavelength Laboratories. Optical Wavelength Laboratories is well known in the fiber optics industry as OWL, or OWL for short, easily recognizable by the owl we use in our logo. OWL's factory is located in America's heartland, providing a high level of innovation and quality. OWL is a family-operated fiber optic test equipment manufacturing company, giving customers friendly and personal service rarely found in the fiber optics industry. In over 20 years in the fiber test industry, OWL has developed more than 17 product lines of quality, reliable, accurate fiber optic test equipment for a wide range of applications. In this time frame, OWL has developed the world's smallest full-powered, full-featured OTDR, as well as DWDM channel monitors and other certification testers, allowing them to become pocket-sized. Fiber optics industries served by OWL test equipment are telecom providers worldwide, both large and small, the premise wiring market, and data centers. OWL has achieved an excellent reputation in the industry. Our many customers and distributors have given OWL's legendary service and quality some of the highest rankings. Overall, customers greatly benefit from working with OWL's friendly, helpful, and knowledgeable staff, and from the quality they have come to expect from US-based manufacturing companies. OWL is committed to continuing its long history of providing quality yet affordable fiber optic test equipment to the telecom, datacom, and data center markets. Thank you for watching our presentation today. We hope you will make OWL your wise choice for your fiber optic test equipment. As a fiber network installer, your customers expect to receive a professional certification report that provides them with comprehensive proof that their network was installed to their specifications. For over 20 years, OWL has built a solid reputation providing installers with affordable options for FiberLink certification, with the latest option being the FiberOwl 7 series. But as you navigate OWL's website, you probably have discovered similar looking versions of FiberOwl 7 testers, these being certification test kits, BIDI testers, and Tier 2 certifiers. So you might ask, what's the difference between them? Which one would be best to meet my particular requirements? Can I get what I need within my budget? So, to help you make the best, most informed choice, this informative video will briefly explain the key differences between the various models of FiberOwl 7 series certifiers. Before we go over the differences between the various FiberOwl 7 series certifiers, however, we should first understand what fiber certifiers in general have in common. All fiber certification testers, including the entirety of the FiberOwl 7 series, use the same standards, follow the same test procedures, and are all typically NIST traceable, just like the rest of the fiber optics industry, all for the purpose of providing common understanding and consistent test results. This effectively serves to level the playing field among certification testers regardless of manufacturer. That being said, what separates OWL's fiber certifiers from other vendors' certification equipment, and what should be high on any installer's list, is OWL's affordability, in many cases saving installers thousands over other vendors' equipment with similar features and functionality. If you have done any research at all on this topic, you understand just how much other vendors charge for their certification testers. So as a quick review, all versions of FiberOwl 7 certifiers have the essential basics of what installers need. Easy job setup to enter information about the link under test, length measurement capability, a key parameter for link budget calculation, accurate standards-based pass-fail results on the screen right in the field, professional certification reports as proof of a job well done, and options available for multi-mode and or single-mode fiber certification. But that's where the similarities end. To get better acquainted with the various versions of the FiberOwl 7 series, we'll start with the version that meets the needs of the widest range of installers, then work our way up from there to cover versions that provide additional benefits for particular applications. Let's start off with the FiberOwl 7 certification test kits. This is the most popular route among OWL's current installer customers, as these kits offer a couple of key benefits. By offering only the features and functionality that are required by cabling standards, FiberOwl 7 test kits keep the test procedures simple, while at the same time keeping the price affordable. These types of power meter light source kits keep things simple by sticking to the minimum requirements of cabling standards. Testing is done one fiber at a time, in one direction, and typically at 2 wavelengths, depending upon which fiber type is used. This type of kit lends itself well to the vast majority of fiber jobs, and especially for small to medium-sized jobs. Within the list of FiberOwl 7 kits on our webpage, there are quite a few different power meter light source combinations, which by itself can be confusing, so I'll try to provide a brief breakdown for better understanding. First, the kits are broken down into 3 categories, based on 3 different feature sets of the FiberOwl 7 series power meter. The FiberOwl 7X, which includes the integrated length tester and is subsequently the most popular option. The FiberOwl 7V, which includes a VFL port alongside the length tester. And third, the basic FiberOwl 7, which contains neither length nor VFL, which means users will have to find an alternative way to measure length, such as OTDR or optical length tester if it becomes necessary. Also keep in mind that this option can also be upgraded to become a 7X or a 7V later on. Then, within each power meter category, flexible light source options are available, including multi-mode and or single-mode fiber sources, auto dual wavelength versus single wave sources, as well as an integrated VFL in some cases. As always, please feel free to contact OWL if you have any questions at all for help. Now, I think this would be a good time to take a brief moment and clear the air about a common misconception about fiber link certification. On the surface, testing a fiber link in both directions might sound logical and more thorough. Yet, according to most conventional fiber cabling standards, testing in both directions is merely optional. Why? Well, think of it this way. Which takes more gas, driving from your house to the store, or driving from the store to your house, assuming you take the same route? The answer is neither. Both directions use the same amount of gas. The same goes for fiber testing. It really doesn't matter whether the fiber is tested from the office to the computer room or from the computer room to the office, because the loss would be the same. Testing in only one direction provides a couple of distinct benefits for installers, saving time by not having to test in the second direction, and saving money by only needing one power meter and one light source in the certification test kit. While most fiber standards make bidirectional testing optional, some customers might insist on their networks being tested in both directions anyway. Using FiberOwl 7 certification test kits like the ones we've been talking about, simply test all of the fibers in one direction first, then swap devices to retest all of the fibers in the opposite direction, although keep in mind that this method will essentially double the time it takes to test the network installation. But there is another option that speeds up the bidirectional process, often cutting testing time in half by testing 2 fibers at the same time, while offering some additional interesting benefits. Keep watching the next video segment to learn more about FiberOwl 7 BIDI dual fiber bidirectional certifiers. As we have just discovered, testing fibers in both directions is not typically required by standards. However, there may be times when the customer wants to go above and beyond the standard and have the fiber network tested in both directions anyway. This is where the FiberOwl 7 BIDI, or Bi-Directional, comes in. OWL's bidirectional testers allow installers to produce the same test reports as the rest of the FiberOwl 7 series, except testing 2 fibers at a time, which provides 2 distinct benefits over single fiber certifiers: saving time by testing 2 fibers at the same time, and automatically measuring the end-to-end length of the cable under test, whereas single fiber certifiers need to have the length measured as a separate process. BIDI test sets can accomplish automated dual fiber testing because they are essentially the equivalent of two single fiber test kits, with each master and remote unit including its own power meter and light source. This is what drives up the cost of BIDI testers. So the installer needs to determine whether the time-saving benefits outweigh the additional test equipment cost. Installers testing small fiber counts may not benefit from the time savings. For example, a BIDI tester may cut an 8-hour day down to 4 hours, not significant enough to justify the additional cost. However, for big jobs that might take several days or weeks or even months, cutting testing time in half suddenly becomes a game changer. Jobs get done twice as fast, allowing installers to move on to the next job much sooner. Plus, this frees up the schedule for additional jobs. So of course, the doubled revenue easily justifies the additional tester cost. So how does dual fiber testing work anyway? Each set of FiberL7 BIDI includes a matching pair of master and remote devices, with each unit including a power meter and a light source. Dual fiber loss measurements and certification is accomplished when the master's light source sends light to the remote's power meter, at the same time that the remote's light source sends light to the master's power meter. In regards to length measurement, since both fibers are connected simultaneously, this essentially creates a loop between the master's light source and the power meter, where the master can record the round-trip time around the loop and convert the time to length using the speed of light equation. But because each BIDI set includes essentially 2 power meters and 2 light sources, this results in a trade-off where you will pay more for the added convenience. So there are certain cases where dual fiber testing is quite an advantage over single fiber testers. Dual fiber testers are especially beneficial in instances where there are a large number of fibers that are identical except for the end-to-end length. 3 distinct advantages of this are multi-dwelling units, or MDU, where an entire building has the same fiber configuration but each apartment is a different distance away from the entrance facility; high-rise buildings, where each floor is served by the same riser cable configuration but each floor has a different length; and finally, data centers, where there may be rows and rows of racks filled with identical fiber lengths, but each rack is a different distance away from the central cabling area. So again, to reiterate what we have learned, cabling standards only require testing in one direction. But does that mean all fibers need to be tested in the same direction? For example, from the computer room to the offices? The answer is no, because direction does not really matter. With a dual fiber tester, fiber 1 can be tested from the computer room to the offices at the same time that fiber 2 is tested from the offices to the computer room. So if you stop to think about it, dual fiber one direction testing is twice as fast as single fiber one direction testing, because you are testing a pair of fibers in the same amount of time that it takes to test individual fibers. And obviously is twice as fast as a dual fiber bidirectional test, because the second direction does not need to be tested. In the FiberL7 BIDI, this is called pair mode, and is the fastest way to certify fibers in accordance to cabling standard requirements. Of course, the FiberL7 BIDI also includes BIDI mode, which is the process where fiber pairs are tested first in one direction, then the test cables are swapped on both ends to test in the opposite direction, before moving on to the next fiber pair. Up to this point, we have discussed what is called Tier 1 certification as defined by the popular TIA 568 cabling standard. But in recent years, there have been calls to implement OTDR link characterization, in other words, a roadmap of the fiber link, into certification reports. With the release of the TIA 568 3.D standard, this has become a reality. Technicians are now allowed to perform what is called a Tier 2 certification test, which is essentially a Tier 1 optical loss pass-fail report with an OTDR trace attached. So if installers also have an Ultrek OTDR, they can manually import OTDR traces into Tier 1 reports from either FiberL7 series certification test kits or from FiberL7 BIDI certifiers. Or installers can opt to use FiberL7 Plus Tier 2 certifiers and streamline the testing process by integrating the OTDR results with the pass-fail data right in the meter. Keep watching to learn more about how the FiberL7 Plus can keep installers competitive while saving thousands over other Tier 2 certifiers. So let's do a quick review. FiberL7 test kits offer the most cost-effective alternatives to standards-based Tier 1 certification. Next, we covered FiberL7 BIDI certifiers that offer Tier 1 certification when the client insists on the installed fiber to be tested in both directions. Finally, we come to the pinnacle of fiber certification testing, commonly called Tier 2 certification as defined by the TIA 568 3.D standard, which is essentially a Tier 1 certification test plus an OTDR test result attached. OWL's FiberL7 Plus series is specifically designed for this purpose, giving installers a distinct edge when competing for Tier 2 projects on the market, while at the same time saving them thousands over other Tier 2 certifiers in the process. But perhaps the most interesting feature here is the ability to add standards-based end-phase quality analysis to Tier 2 test reports, resulting in what is perhaps the most comprehensive test report available for fiber networks. We call this a tri-report, since 3 reports are included on one page. Here we see a section of the Tier 1 pass-fail test report, a section for OTDR link characterization, and a section for quality analysis of installed fiber end faces. As an installer, if you offer a tri-report while your competitor only offers a basic certification report, which one would your client choose? Aside from tri-reports, FiberL7 Plus certifiers also have a flexible range of testing applications, including basic optical power measurement, end-to-end loss measurement, and Tier 1 certification. And the OTDR port can also be used as a standalone OTDR for troubleshooting purposes. Each 7 Plus certifier also includes an integrated visual fault locator for additional basic troubleshooting functionality. So to summarize, no matter what level of fiber optic link certification you need, the FiberL7 series has you covered. We thank you for taking the time to watch this presentation today. We realize that there are quite a few options to consider, so if you have any questions or need a recommendation, feel free to give us a call at 262-473-0643 or visit owl-inc.com.